Right. Good morning, everyone. I guess my voice is loud and clear to all of you. Turn your cameras on. The discussion. Mhm. Guys, can anybody send the link of the session to the group? Good morning, Lakshmi. Would you be able to do it? All right. All right. Okay. Just give me a sec. Elizabeth, you have sent it, right?
Yes, sir.
Okay. I can't have my phone till NEET, so I need to send it out on mail. You're gonna send your doubts on mail? Sure. All right. Have it. It's ANIK, Anik, then dot, then GHSH, Kosh, @askIITians.com. Okay. And that way you can find any teacher's email ID, isn't it? Just need to name the first name, then dot the second name, then @askIITians. Okay. All right, you're welcome. Okay, guys, I guess you have given the last test, the physical chemistry test. What you have to do is, you have to go through those kind of questions. Like I have mentioned in the, voice message as well. You are not supposed to expect that same exact question, but similar to it. Like I have given you, let's say I've given you a question of a particular cell. So you just go through a little bit of other type of cell as well for that particular kind of question. All right. So this is what you have to do. So today, what I would be doing is I have picked up some particular things that I feel like you might have missed again. And I'm going to talk about those things. First of all, guys, I just want to know your ideas about it. So first, I'm going to talk about the cells, the batteries, like the nickel cadmium cell, the lead storage cell. So how good are you with those things? Would you just write it down in the chat? How do you feel about those different cells, dry cells? What is the electrolyte in it? Sir, I don't get the link in yes, Anisha. I would be asking the support team to do that because you were added up a little late. For others, they have the information. For you, I think they do not. I'll just send a mail to them. Okay, you guys are doing great with that. How are you feeling about this? That I learned from the NCERT textbook for the boards. All right. Okay, that's one thing. You are fine with it. Okay, great. Okay, for the boards level, you have done it from the NCERT. So just give me one exact some answer to some questions. First of all, what is the electrolyte that we use in let's say dry cell? What would you say? The electrolyte used in dry cell. Is that what is written in the NCERT? Because there is something else as well. All right. No, Ashini, not that one. NH4Cl is coupled with ZnCl2 as well. Okay. Anyways, just tell me one more thing. What is the concentration of H2SO4 that we use as an electrolyte when you are talking about the yes, Harshini, very good. And the density? Density? When the density changes, what is the exact density from where when it changes, you need to recharge the battery? Okay, see, I would just give you a brief idea about all those four cells real quick, okay? So that I would be satisfied that you won't miss anything. Okay, the cells were the one thing. Then I was thinking about in physical chemistry, there is one type of question coming with respect to the relations. Now, these relations are not really, they're giving any values to it. They're doing this completely on the basis of the what do we call it? Like, you do understand what type of question I'm saying? Like, what is the relation between molarity and molality? The value would be like m equals to rho m1 m2 divided by 1000 into 1 minus m1 m2, that kind of thing. These kind of questions have been asked before as well. So I'm going to talk about these kind of questions a little bit today. Then the cells in detailed manner, like up to whatever level they ask you the question, there wouldn't be anything that, guys, you'd be missing. And I would be trying to make it a little bit easier for you to remember as well. Okay, we are putting some logics in. There was logic before as well, so I'll just try to show you a little bit more. Then, guys, one more thing is the configuration of the actinoids and the lanthanoids. Lanthanoid electronic configuration is fine. I guess you are fine with lanthanoid electronic configuration. How are you doing with the actinoid electronic configuration? Have you looked into it? Because see, last year they gave you a question why GD3 plus is stable, right? Gadolinium 3 plus is stable. That is from lanthanoids. So this year we can expect a question coming from actinoids definitely. And guys, I guess by the question paper that I have sent you, I guess you have seen that I am trying to give some assertion reason based questions, right? You can expect a lot of assertion reason questions this year based on the last year's paper. I guess you have noticed the last year's paper as well. So guys, let's give it a go quickly. All right. The first thing is the relation between M molarity and molality. We know about it, but still we are going to do it with respect to the abbreviations right now. So first of all, when they ask you the question, there are some certain abbreviations that they maintain every time. If they tell you, then that's well and good, guys. If they don't tell you, you need to remember this. Maybe I mean you mugged it up, is it? See, if they give you the question, then in that case, if they do not mention all the things for you, then always remember M1 is the molar mass of solvent. If they do not mention, this is a standardized version, guys. M2 is always the molar mass of solute. Okay, always remember this. And they can give you as rho or D, anything as the density. Whenever they give you density, always remember, guys, they are not giving you with respect to gram per liter. They are giving you with respect to gram per ml or gram per cc. Okay, any of these two things. These are the standardized values. Now, when you start doing this question relation between M, so guys, first when you write the molarity thing, what is molarity for us? The number of moles of solute in 1 liter solvent. Again, guys, you won't be solution. You won't be in your exact state of mind which you are right now or when you are giving my test. So always remember, when this kind of situation comes, first of all, skip these kind of questions right away the moment you see it. Solve the rest of the paper. Then when you have some time, you come back and solve this question. Okay, and start from the very basic, guys. You would be lost in the road. You'd be lost in between. Start from the very basic whenever it happens. All right. Now, number of moles of solute in 1 liter of solute. So let's say there are m moles of solute. Okay, let's consider that there are m moles of solute. Okay. Now I have, can you share the answers of the test? Yes, I mean, I guess the answers are being shared over there, isn't it? The moment you submit it, you do get to see the answers, isn't it? There are some answers were wrong. I have changed it and I have given you marks accordingly. So some of you are getting some -4 and then +4. That's why maybe your marks is just the same. But all the marks has been revised. Okay, so if you are getting a same marks, doesn't mean that I haven't checked it. You are getting some negative marking and then you are getting some positive marking. Together, that is making it that value. Okay. Now let's say m moles of solutes are there in 1000 liters of solution. So guys, in order to make it molality, always write them down. So number of moles of solute in 1000 grams, or let's say 1 kg, whatever, of solvent is what you need. So see, number of moles is m, that is what we have. We need to convert 1 liter solution to 1000 grams, means mass. So first guys, 1 liter to mass, how would I convert it? So I have density is rho. Okay, so if I go like 1 liter equals to 1000 ml, because why am I doing it 1000 ml guys? Because I'm gonna make it with respect to grams. So 1000 ml to 1000 grams. That is more logical. So 1000 into rho would be the mass of solution. See, 1000 ml is the volume of solution, right? Rho is the density of solution. Is the density of solution. So guys, by multiplying them together, I would get the mass of the solution. Correct? Now, from the mass of the solution, I have to subtract the mass of the solute in order to get the mass of the solvent, right? So I would subtract the mass of the solute from here now. So what is the mass of the solute, guys? This is the number of moles of the solute given to you. And I told you, in a general manner, we always consider M2 as the molar mass of the solute. So if I go like number of mole into molar mass, that gives you the mass of the solute. Tell me, is that clear? Number of moles is M moles of solute are there, which I have already told you, and M2 is the molar mass of the solute. So M into M2 would be mass of the solute. How do I know that, guys? You know that quantity, number of moles equals to quantity by reference. Reference is my molar mass. Quantity is what you want. Number of moles is M. I told you this already. So M into MT is the quantity, the mass that you are looking for, right? So this is what we have as the mass of the solute, and this is mass of the solution. So guys, now I have the mass of the, what is this? This entire 1000 into rho minus M1 and 2. This entire thing is the mass of the solvent. Would you just write it down in the chat real quick? Are we clear up to this? Are we clear up to the mass of the solvent? Everyone? Good. If you are clear up to this, now guys, this mass is done in grams, right? You have to convert into kg. So what would you have to do? Divided by 1000. So M divided by 1000 rho minus M2 divided by 1000. So it would go in the multiplication. All right. So in the end, guys, so what is the formula of molality coming then? Molality is coming as 1000 M divided by 1000 rho minus M2. This is what you had to do. Now, on the basis of what they're asking in the question, you need to simplify it. See, when they give the question, you need to make sure that what they actually wants you to do as actually, they want to convert molarity to molality. So you need to keep the M in one side and the small m in the other side. So if that kind of question comes, so you know what you need to do here, right? You just do some simplification in here. So M would be equals to M by, I'm dividing everything with 1000 now, rho minus M2 divided by 1000. These things are all only based on whatever they are asking you. So that would be giving you as let's multiply this thing in the other side. So M rho minus M2 M divided by, sir, M is the number of moles. Exactly, M is the number of moles of the solid. Okay, M is the number of moles of the solute. Okay, so in 1000 equals to M. Okay, so that means M rho equals to M plus M2 M by 1000. Then take M as a common, 1 plus m small m 5000. And guys, this is m row. Now the value of m is m row divided by 1 plus m by 1000. See, all these things that I'm doing on basis of what I have seen the questions coming, you can do it, right? First, the major thing is you need to find this. I would suggest you strongly that that you remember this, so that's a very good thing. But I would suggest you guys don't try to do it right now. Don't try to remember it anymore. If you do it, then that's fine. But don't try to remember it because it's not really that difficult to do. It's a very simple thing that I am just finding out from the basics. Take some time right after the session is over and just try to do it once on your own. Okay, so this is the entire proof, guys. The yellow part is not really necessary. Okay, the green part is this. Elizabeth, clear?
Yes, sir.
Okay, now moving on to the next one, next relation. So you do this for me. Relationship between molality and mole fraction. Could you try it, guys? Molality and mole fraction. Mole fraction, you can take it as x2 is the mole fraction of solute. And if I solute, and if I write x1, that is for solvent. So 1 always denotes solvent. Try it now. Do write the definitions. That makes it a little easy for you. Both the definitions. All right, I need to check that. Excuse me. Do you memorize all the relations, Amin? What if they ask you something different? Most asked one. But let's say they asked you the molality one only, but they asked a different way. What would you do in that situation then? You would be able to figure it out as well, right? You know the process as well, right? Yes. If you know the process, you can just go on and remember it. It's fine. But how much would you remember in this way? Isn't it a lot to remember in bio? It does increase speed, but it decreases your marks as well if you forget something. बायो में तो वैसे भी बहुत कुछ रिमेम्बर करना होता है ना सर बायो के बारे में कुछ गलत मत बोलिए केमिस्ट्री में ज्यादा रिमेम्बर करना होता है All right. All right, Ashni. If you can just find out the relation with respect to x2, then also it works, guys. Because x1 is 1 minus x2. Guys, this time I'm gonna tell you. So what it's WA into WB by WB. That's correct, Mahika, but you are saying it with respect to the solution chapter, isn't it? I got it. Um, see, when we talk about molality, they go like number of moles of solute divided by 1,000 grams of solvent, right? Now, what you actually have to do is, guys, to get mole fraction, to get mole fraction means X. It's the number of moles of a substance divided by the total number of moles. So that means what do I need, guys, to find this out? What do I need? I need the number of moles of solute and the number of moles of solvent, isn't it? Agreed, guys? That is what you need. See, you have the mass of solvent. So how can you find the number of moles from there? You have the number of moles of solute already. So guys, you can consider the number of moles of solute as capital M. So capital M is the number of moles of solute. 1,000 gram is the mass of the solvent. So 1,000 divided by, for solvent, what was the told you guys what was the like standardized standardized value, which is M2, right? M2 is the standardized value here. So 1,000 divided by M2. So there, by doing this, what I got is I got the moles of solvent. And guys, this is the moles of solute, right? So now it's pretty fine. You can just figure out what is the mole fraction from here. So if I want the mole fraction of A, let's say I want the mole fraction of solvent. 1 means always solvent. 2 means always solute. So if I want the mole fraction of solvent, then the mole fraction of solvent is a mole of solvent. What is the mole of solvent coming? 1,000 grams by M2. So 1,000 divided by M2. This is the number of moles of solvent divided by total number of 1,000 divided by M2 plus M was the mole of the solute, isn't it? M was the mole of the solute. So this is going to be the equation. Now, on the basis of what they ask you, you just convert it. Always remember one thing, guys. If they ask you with respect to x2, you know that 1 minus x1 equals to x2. You can convert it the way you want it, the way they ask the question. Forming this is what matters, guys. Then the final equation you can derive from here. This is what matters.
Sir, aren't we supposed to take M1 for moles of solvent?
M1 for moles of
Solvent?
oh yes, M1. What did I took earlier? M2. Very good. Okay. So that was the second thing. And the third thing was relation between molarity and mole fraction. So I guess now you can do it on your own completely, guys. Give it a try. Put a little bit more pressure on inorganic chemistry because that's what's gonna take the most weightage this time. X2 by X1 into 22.4. Why is that, Arshini?
So, x2 by x1 will give you the ratio of the number of moles of solute and solvent.
Okay.
So the numerator you have the number of moles of solute. Denominator you have the number of moles of solvent multiplied by 22.4. That will give you the volume of the. Okay. Okay, sir, I made a mistake.
That was not a gas, right? Guys, I guess you have found something. Let's see whether that matches with the calculation right now or not. So molarity, when you talk about that, this is number of moles of solute divided by 1 liter of solution. Okay. Like I said, guys, always remember, always write 1000 ml. Number of moles of solute is 1000 m. Just one second. Number of moles of solute is 1000 m. Why, Maika? I didn't get that. M is the number of moles of solute. Only M. Okay. So 1000 ml solution. Now, guys, what's the target? Mole fraction. To find mole fraction, you need the number of moles of solute as well as number of moles of solvent. So I have the number of moles of solute as capital M. In molarity, I do have it. What I need is number of moles of solvent. So, guys, what you have to do? See, this is the number of moles. This is the volume of solution is what given to you. Volume of solution is what given to you. So, from volume of solution, what you need to convert is from the volume of solution, you multiply it with rho. Rho was the density of the solution. So by multiplying them together, we got the mass of the solution. Now, if M is the number of moles of solute and M1 is the M2, right? M2 is the molar mass of solute. Molar mass of solute. Then, guys, M into M2 is the mass of solute, right? M into M2 is the mass of solute. Again, because of number of moles equals to quantity by reference. Reference is the molar mass. Number of moles I am giving you M. So what is the mass then? Required mass would be M into M2. So that means 1000 into rho is the mass of the solution minus mass of the solute is MM2. This gives you the mass of the solvent. If this is the mass of the solvent, but guys, I need number of moles of solvent. So what would that be? Mass divided by molar mass. So number of moles would be 1000 into rho minus MM2. This is the mass divided by molar mass, which is M1. Now I got the number of moles of solvent. Now, guys, when they ask you the whatever they ask you on the basis of which mole fraction are they asking? Let's say they are asking the mole fraction of the solvent. Sorry, write it like this: solvent. Then on the basis of that, you'd be doing it. So number of moles of solvent would be 1000 rho minus MM2 divided by M1 by total. Total would be 1000 rho minus m into by m1 plus solute is. These are the number of moles of the solvent. Solute, I guess you would be able to figure out m divided by 1000 rho minus m into by m1. Guys, this final equation, they do look scary. I do understand that. But then again, you just approach it logic by logic. Don't try to remember the final equation. Don't feel like, okay, this is a very big equation and all. Don't go like that. I'm just doing with respect to logic, step by step. Don't do that, Maika. Don't do that. Don't try to mug it up. Okay, go step by step. This is not very difficult. See, I got the mass of solution, volume of solution. I need the mass. Then I need the molar. So if I need the mass, I need to multiply with density. This is the mass of the solution what I got, minus mass of the solvent, minus mass of the solute. So how do I find out the mass of the solute? This is the number of moles into molar mass. Multiplying them, I get the mass of the solute. So now this is the mass of the solute. And what is this? This is the mass of the solution. So if I just subtract them, I would get the mass of the solvent. The moment I got mass of the solvent, what do I need? Do I need mass? No, I need the number of moles. So mass divided by molar mass, which is this, gives me the number of moles. Now, the moment you found out number of moles, you just do it with respect to that. Take some time, practice them once or twice, and try to understand every step that you do. Okay. Otherwise, don't try to mug it up. That would be very difficult. Amin has done it because he's saying that he has solved these questions number of times. So it's like he has a picture in his head, something like that. That works, guys. But you know, when you are in a huge amount of pressure, now, let me tell you, this is going to happen. You have never been in that situation. Only a few of you have been there, actually, those who have given JEE. So other than that, guys, you don't really, even if you have given JEE, still, actually what happens is this was not the exam you were preparing for. This is the exam you have given your 2 years for, isn't it? So if you are feeling a little bit nervous, if you feel like, okay, I don't know what's going to happen, and you have lost your appetite, guys, this is what's supposed to happen with you. So whatever is going on right now, it's completely natural, it's completely normal. But remember one thing, I'll be sending you a message right before the day of the exam, and do read it. Okay, don't go like, okay, this guy says a lot of things, so you can just skip 1 or 2 things. Don't do that. Okay, do read it, because that is, I'm going to tell you some things that is going to help you just before you start an exam. Okay, you are nervous, you see around you, then you see those, those faces, those who are like pretty much sad, or I don't know, mix of expressions and all, right? At that situation, what you need to do to keep it together, guys, if your first question or if your first 2 questions, you get that, then you are going to crack this exam. But what would happen if you don't solve the first 2 questions? You don't really know what's going to happen, isn't it? So how to keep yourself together, how to come back at that situation. I have given near about 20 competitive exams by this day right now. I don't know how many I'm going to give later on. And every single exams were, guys, deciding my future, my career, every single time. So let me tell you, I have been through this situation almost at about 18 to 20 times. From there, I have gathered some things which helps you actually to keep yourself together. First thing. Second thing is to be at right state of your mind, because there's a lot of distraction at that moment that you might be feeling. Okay, so I'll be telling you what are the things you needed to do right now. Whatever is going on, guys, don't feel like, okay, I'm losing everything, everything's out of my hand. There's nothing out of your hand. You are trying, that's why you are in the situation. All right, now the cells, real quick, I'm going to tell you about them. So the first thing about the cells are, there are 2 types of cells, primary cells and the secondary cells. Primary cells are the cells that you cannot recharge. Secondary cells are the cells that you can recharge. Okay. So guys, if somebody asks you which of the following is a reversible cell, primary cells or secondary cells? See, simple, it's going to be secondary cell. Reversible means you can recharge it. It's a kind of a cycle that you're going to see in here. Now, when you're coming to the primary cell, the first cell that you're going to start with is called dry cell. Okay, tri-cell is nothing but the battery that we use in our AC or remote where we use the battery. That's the dicer. The coating that you see on the outer layer of the battery, that is actually a layer of iron, nickel, and zinc all together. In your book, it is written as zinc. But what actually happens is, guys, all the statement that I'm making right now, everything is important. Okay. Earlier, we used to use only zinc. But guys, when you're doing this reaction, what actually happens is zinc is a part of this reaction. Okay, zinc is used, as you can see over here, zinc casting is used as an anode. So what happens is over the period of time, the zinc gets corroded. And after a certain period of time, if you do not give an iron or a nickel alloy in here, putting in here, what actually happens is your cell starts making leakages. So all the inside solution, they start coming out from the battery. Okay, to avoid doing that, we have given a layer of iron and nickel on the top of the zinc. Okay, now if you just pay attention to the picture over here. Okay, try to remember this picture. Okay, don't try to remember any equations or anything. See, this is the outer coating. This is made up of the zinc. Here, zinc is an anode for us. Okay, now always remember, guys, when we say anode and when we say cathode, before I write the equation, always remember anode starts with A, cathode starts with C. You don't have to remember that. But the point is, what you have to remember is, as it is alphabetically coming first, always remember oxidation, what happens in here. So anode undergoes oxidation, cathode undergoes reduction with respect to alphabetics. Okay. Now, zinc casting is my anode here. Now, this blue layer is the zinc layer, the anode layer. Now, what is the cathode over here, guys? Cathode is a carbon rod or graphite rod. Lone left side oxidation anode. Oh, zone. All right. Yeah, that works. So as I was saying, so this is carbon. Haven't they written that? No, they have forgotten to write. Forgot to write it. So this is carbon or graphite, you can say. Specifically, graphite is what we use. Now, on the graphite, this is my cathode. But guys, if they ask you what is the cathode, don't just write graphite, because that's not the cathode. The cathode is graphite with the manganese dioxide together. Okay, because manganese dioxide is the thing which is going to react, guys. So if you only write MnO2, then also it's wrong. If you only write graphite, that also is wrong. MnO2 is the one which is going to react. So guys, MnO2 has to be there. So MnO2 layer, like this thing that you see, the light blue thing in here, in both the sides, this is the manganese dioxide liquid presented. Okay. So what else do I have? Guys, if they ask you what is the electrolyte in here, that is NH4Cl. But with NH4Cl, we give a little bit of zinc chloride in there as well to increase its conductivity. So this is, guys, the entire thing, entire setup. So guys, there is a zinc layer. On the inside of it, we got the NH4Cl, ZnCl2 layer. Paste. Inside it, we have the MnO2. Inside it, we have the cathode, which is my graphite. Okay. So this is the entire thing. Now, one more thing that you have to see. Okay, they haven't told you anything about that. Okay. Now, what are the reactions, guys? Tell me, Harshini, what is the reaction in the anode for dry cell? Guys, keep your cameras on.
The zinc gets oxidized. Zn becomes Zn2 plus and 2 electrons.
Zn2 plus and 2 electron. And what is the anode reaction?
The manganese changes from +4 to +3 oxidation state.
So MnO2 becomes MnOOH. Okay. So guys, manganese becomes MnOOH. This is the final product of this. Now, not only manganese dioxide, we have ammonium chloride present in here as well, NH4 plus. That's also there. Now, what actually happens is this ammonium chloride, it also converts into ammonia. But guys, don't try to remember this again, because see, this is nothing really changing in here. If you have a look in here, what is the oxidation state of nitrogen? You would find it as -3. If you find the oxidation state of nitrogen here, that would also be -3. So guys, this ammonium to ammonia, oh yes. So guys, ammonium to ammonia is not really a change happening. What is it doing, guys? Here, ammonium is a proton donor in this reaction. So if they ask you in the dry cell, which particular compound acts like an acid? So the answer is going to be NH4 plus, NH4Cl. NH4Cl, NH4 plus is acting like an acid, who is actually giving the H plus to the reaction. Okay. Now the point is, if you see, I haven't really transferred any electrons in here, right? Now, if you see that manganese, the oxidation state is coming as +4, and this is +3. All right. Yes, I'm coming to the doubts, all the doubts you have in the chat just after this. So +4 to +3. So guys, how many electron transfer process is this? Single electron transfer process. Right, Anisha? Just one single electron has been transferred here. But you see, that previous reaction that I have written, there are 2 electron transferred. Here, there is only 1 electron transferred. See, the point is, guys, have you ever seen a reaction? Have you ever written any reaction where you have written the electron in the reactant or the product? You have never done that, right? So that means the electrons needed to be cancelled out. So for that, what you have to do is, you have to multiply the second equation with 2. If you do that, what's the equation coming then? 2NH3, NH4 plus 2MnO2 plus 2 electron gives you 2MnOOH plus ammonia. Now you add it with the first reaction now. So the first reaction goes like zinc plus so zinc turns into Zn2 plus. Now if you add this 2 equation up, you can clearly see that the electrons are getting cancelled out. So guys, when they ask you the final equation, you just do this both of the steps and then you find out the final equation. See, our target is, I do understand, I do believe in you that you can remember all these things together. But then again, guys, at that situation, we don't really know what kind of silly mistakes that we would do. So always start from the basic and go to the end so that you don't make any simple silly mistakes in there. All right. So guys, write down the final equation now. Done. 2NH4 plus 2MnO2 plus zinc gives you Zn2 plus 2MnOOH plus NH3. Okay, that's the first equation. Now, what is the name of MnOOH? See, it's a complete. Do you remember that mixed oxide thing like Fe3O4? Remember that thing, ferrosulfuric oxide? This is kind of that kind of an oxide. We go like manganese oxyhydroxide. That's the name of this molecule. This is actually a kind of an ore. So otherwise we call it manganese oxyhydroxide. Manganese oxyhydroxide. Kind of a mixed oxide kind of a. Okay. All right, guys. So one more time together. We have a zinc coating in the outermost layer. Try to visualize this. So there is a zinc coating, the blue colored zinc coating in the outline. That is actually our anode. Then on the inside of it, what do we have, guys? NH4Cl and ZnCl2 paste. That is my electrolyte. This NH4Cl is actually used because it helps as a proton transfer in these equations. You can clearly see that. Now, inside it, what do I have? MnO2. Very good. MnO2, and then we have the graphite or the carbon rod. The carbon rod is my cathode. But carbon rod is not the one which is reacting in here. MnO2 is the one who is reacting. So guys, we need to mention the MnO2's part over here. Now what actually happens is, the anode reaction is pretty simple, guys. Zinc is turning into Zn2. So no such problem is happening in there. This is the reason why on these cells are not long, they do not have a very longevity. Because on the base, on the, when the reactions are going on, the zinc is getting used up, right? So after a time, this cell wall would be this wall. This is not that cell wall. This is dry cell wall, what I'm talking about. That would be thinner with time, isn't it? And then one time it would start leaking. So for that, what we have done is, guys, we have used the iron and nickel coating on the top. Now onwards. Okay. Then guys, this first reaction is simple. Second reaction, always remember that MnO2 is the one undergoing reaction. NH4 plus supposed to be written in there, which is just helping in the hydrogen transfer. Okay. I guess that's fine, sir. What's the purpose of the graphite? Like Harshini, graphite or carbon, they help you in conducting electricity, isn't it? So that is the only purpose of from this reaction, the electron which is coming out, graphite is helping to conduct. And over there, zinc is helping to convert that, because zinc is any which way is the metal, right? Okay, guys, clear? Now, coming to the next one, which is the mercury cell. See, when you hear the name mercury, you do understand mercury would be one of the, component. So, Laksha, would you be able to tell me what was the reaction in the cathode and the anode? Start with the anode first.
So it's the same anode reaction, zinc gets oxidized.
Great, it's the same anode reaction. But before that, guys, I forgot to tell you about the how it is being made. So have you seen these kind of cells, like lithium battery, or what we call it, mercury battery? Like, they are very small battery, and we use it actually in all those what do we call it, watches. Definitely watches, we use it. And all those, how can I forget this, guys? What is the name of the things that you play with when you were a child? What do you call that thing? Toys, exactly. In those electronic toys, yes, exactly, electronic toys is where we use it. Okay, so that small batteries is what I'm talking about. Okay, I mean, you are right there, right? Yes, he's gone. Oh yeah, he's there. All right. I do have trust issues with you guys. Okay, anyway, coming to the point. So what we have in here, guys, see, the anode is not changing. It is zinc, but there is a small change in here, guys. The zinc rod, the zinc was getting corroded, isn't it? That's the problem that we had before. So here what we actually do is, we don't use the normal zinc rod. I don't know whether it's written in the NCERT or not. We use zinc amalgam. We use amalgamated zinc in here. All right. So guys, the anode is it is written, great, amalgamated zinc. Okay. Now, what is the cathode in here? Here, cathode is mercuric oxide. See, this was not really something that you, not like you couldn't assess it. Before as well, you have used a cathode which was an oxide of a metal. Here, when you come to the mercury cell, they are already telling you that mercury is the metal. So you have to use the oxide of mercury in here. Earlier it was manganese oxide, this is mercuric oxide, same thing. So now, what actually going to happen is, here what is the electrolyte in here? Earlier, what was that, guys? NH4Cl and ZnCl2 mixture. Here, what is the electrolyte? Here, it is ZnO and KOH. KOH and ZnO. This is the mixture that we are going to use. See, you would be finding, like right now, it's a topic of remembering to you. But when I tell you about the reactions, you would be able to understand the logic. What is the need of every single thing here? So first, guys, what is happening in the anode? So the anode reaction remains the same, amalgam. Nothing really changing for the amalgamation, guys. Zn2 plus. So see, in the first reaction and the second reaction, both the cells, the anode reaction is same. Now, if I talk about the cathode reaction, here, let's see what's gonna happen. Okay, guys, would you do one thing for me? Do you see that zinc amalgam is the anode for me? What is the electrolyte, by the way? ZnO, isn't it? So rather than writing Zn2 plus, would you just write ZnO for me? I don't think so. That would be a very difficult job for you to do, right? But the moment you write ZnO, there is a problem that we have now. The reaction isn't balanced. So guys, we have to balance this equation. Now you have learned balancing equation in two ways. In the acidic medium, in the basic medium, right? Which medium am I gonna use? Here, basic medium. Are we finding the logic in here, guys? So if you have to do the balancing in basic medium, do we remember the ways of balancing it? Tell me. First, what you have to do is you have to find out you have to balance the atoms. Okay. Then what is the next thing to do, Priyadarshini? After atom, what do we balance next?
Oxygen.
Oxidation number. After oxidation number, guys, what do we balance next? Then we balance the electron, the charges. After oxidation number, we balance the charges. Guys, are we having issues with this? The ion electron method balancing? If you do have it, just listen to this, okay? First, you need to balance the atoms. Then you need to balance the oxidation number. Then you need to balance the charges. Then you balance the oxygen. And then you balance the hydrogen. Okay, so this is what you have to do. Now, what all tools that you have? Now, see, to balance atoms, you can use the mathematical numbers 1, 2, 3, 4, these kind of numbers. To balance the oxidation number, the tool that you have to use is electron. So, guys, how am I gonna balance the oxidation number? By using electrons. Third tool. The third is balance the charges. To balance the charges, you have the tool of H plus or OH minus, depending on which medium you are using. If you are doing it in an acidic medium, then H plus. If you are doing it in the basic medium, then OH minus. Okay. Oxygen. Always remember, to balance oxygen in acidic medium, you are going to try to use water in both the medium. So I'm going to write water right now. And to balance hydrogen, you can add H plus or OH minus. But guys, actually what happens is, this step you don't really have to do. If you do the previous steps correctly, then the last step you don't have to do. It would be balanced anyway. Okay, let's try it now. So guys, let's balance the atoms first. So Priyadarshini, as we can see, zinc on the left hand side, I have 1. On the right hand side, I have 1. Okay, let's not write these electrons or something. I have 1. You might say, sir, there is an oxygen in here. Don't worry, I am going to balance oxygen in the steps. Not right now. Okay, zinc is balanced. The next thing is balance the oxidation number. Guys, find out the oxidation number here. This is 0 because this is in the free state, and this is +2. Right? Clear? Now, how do I balance the oxidation number here, guys? They're saying you need to balance the oxidation number by electrons. So what am I going to do? I'm going to add 2 electrons on the right hand side because electrons are negative. This is positive. They are going to be 0. So this is also 0. This is also 0. Done. Right when you have done doing that, the first thing that you have to do, guys, is do anything to get rid of these numbers on the top. Cut it or do whatever you can, write it in a fresh way. Don't let those numbers flash in front of you anymore, because you'll be making a big mistake if you keep them. And I'm not going to tell you what's the mistake, because if I tell you, you are definitely going to make the mistake. All right. So don't, just get rid of those numbers, the oxidation numbers. Now, guys, the third thing that you have to do is balance the charges. So would you check what all charges do I have on the left hand side? Do I have any charge, guys? Any plus, any minus, anything? No. On the right hand side, I have 2 electrons. So -2, isn't it? So if I have -2 now, guys, how am I going to balance it? What is the tool that I have? H plus or OH minus? What tool do I have in this equation? OH minus, because it is in KOH, right? The electrolyte was KOH. So I have OH minus over here. Right, Anisha? Right, Ami? So how many OH minus am I going to use? In which direction? In which place? See, the overall charge is -2 on the right hand side. So I'm going to add 2 OH minus on the left hand side to balance the charges. Do we understand this? Clear? Right after this, the next step is to balance the oxygen. Guys, in the left hand side, I can see I have 2 oxygen. On the right hand side, I can see I have 1 oxygen. What is the tool I have? Water. So guys, how many water and which side? On the right hand side, I would get 1 water. Now see, oxygen is balanced in both the sides. Right? Now, like I said, if you do everything correctly, then you don't have to balance hydrogen. Check it, your hydrogen is balanced. See, here I have 2 hydrogens, here I have 2 hydrogens already. See guys, now entire equation is balanced. This is the exact equation written in your book. So guys, we just need to remember the conversion. Who is converting into what? Don't try to remember anything about that. Okay? Let's try it one more time for the anodic reaction. So this was the anode reaction. Then let's write the cathode reaction. What was the cathode reaction, guys? Cathode, who is turning into what? Like I said, this is a mercury cell. So I am gonna have an oxide of mercury. Before I had an oxide of manganese. Here I have an oxide of mercury, which is getting converted into what? It is getting converted into mercury. Okay. Now, would you try to balance this entire thing, guys, on your own? Mercuric oxide to mercury, using the steps that I told you. Done, guys? If you're done, then just raise your hand. Okay, Harshini, you have written it. Perfect. Right, Anisha, very good. So guys, tell me, Priyadashini, tell me what is the answer you got?
So the HgO plus 2 electron plus H2O gives Hg plus 2OH minus.
Perfect. Now, guys, what was the final equation then? Just add them up. Then you got the final equation. These are the equations written in your book. Just check them. If you are thorough with this method, now what actually happens is in the chapter D and F log. Do you remember there was a tons of reaction in KMNO4 and K2CR207 section? Just nod your head if you do not remember, don't give me a heart attack right now. You do, right? Just go through those equations as well. They can also be done in this method. Okay. So guys, this was the second equation we had. I think so. The first case we have the electrolytes in H4Cl, ZnCl2. Here I have the electrolytes KOH and ZNO. Now I guess you do understand what is the need of both of them. KOH is making it a basic medium, and the ZNO is what you are converting it into. Okay. So these are the two things. All clear, guys? I'm moving on from here. Third thing is secondary cells. So the secondary cells, when we talk about that, we have 2 types of secondary cells. The first one is the lead storage cell, and then I have the nickel cadmium cell. See, the lead storage cell, when you talk about that, it's a rechargeable now. From here onwards, it's rechargeable. So guys, all of these cells are reversible in nature. Okay. Now coming to the first one, which is the lead storage cell. So guys, you do understand lead has to do something with it. As you can see here, These are the two cells, like right here. So I am going to zoom it in and I'm going to show you in this picture. So guys, this is the cathode, this is the anode, this is the cathode, this is an anode, this is the cathode, this is an anode. So it just goes on like that. Okay. So I'm zooming this one cell in and showing you in the right hand side. So what are they writing, guys? The cathode, what is the cathode reaction going on, guys? In the cathode, we have PbO2. And what is happening in the anode? In the anode, we have lead. Now, what is the electrolyte over here, guys? Dilute H2SO4. 38%, 1.2 gram per ml. This is going to be the density. Density is important, guys, because the moment the density goes down, you need to this one, sir. Is everything all right with my screen sharing, or the light got dimmed? It's fine, right? I don't know what's really happened. Now, like I was saying, guys, here my electrolyte is dilute H2SO. So do you understand the PbO2 would also get converted, would also react with H2SO4, and the Pb would also react with H2SO4. H2SO4 is a common medium in here, right? So let's do the first things first. In anode, what actually happens is, guys, always remember the metal leaves electron in here. Okay, this Pb2 plus that you have, this is what actually reacts with H2SO4 and just makes PbSO. So nothing really in here. On the left hand side, what you have to do is, guys, this PbO2, here Pb turns into Pb2 plus. What was Pb? 0. 0 to plus 2, this is oxidation. But on the right hand side, this is plus 4, lead is in plus 4. Now from plus 4, it turns into Pb2. So plus 4 to plus 2, this is reduction. Now guys, quickly solve this balance part in here in this section, real quick. Balance this equation. PbO2 to Pb, 2 plus. And the Pb2 plus that you form, that's again going to react with this for 2 minus. Same reaction both the place. No, not the same reaction happening here. Pb is turning into Pb2. And Pb2 plus means it is PbSO. And here PbO2 is turning into Pb2. Pb2 plus means again PbSO. Very good, Harshit. Very good, Maika. I'm glad that you have noticed. Let's see if there is anybody who makes a mistake here. Where is Elizabeth, by the way? She left. Is it done? Very good, Anisha. But isn't it the final equation that you're writing? You don't have to write the final equation too. Just tell me how's the balancing for this. Relation, is it done? Okay. Laksha? हाँ, ठीक है. After this, I'll just tell you the lanthanide actinide configuration. This is needed. Hello? Hello? I guess you're done, guys. See, the only thing you need to notice in here was it is not in the basic medium anymore. It's an acidic medium system, right? So what you had to do is first you balance the number of lead, which is balanced. Then you balance the number of oxidation states, right? Oxidation state is +4 to +2. So what you're going to do is you're going to add 2 electrons on the left-hand side to balance the oxidation state. The moment your oxidation state is balanced, the next thing is to balance the charges. I told you before you balance the charges, you get rid of the oxidation state. Otherwise, you might make a mistake. This is the not the oxidation, this is the charge. So wait a second. Just the charge is balanced, isn't it? In the left and the right. Let's just see. It's not. Let's write it down. Where am I making mistake? If I consider the charge is balanced, then water 2H2O and then 4H plus. Is this the equation that you got, guys? You got this only, na? So the charge was balanced. So then I added the I tried to balance the oxygen by adding water, and then to balance the hydrogen, I added 4H plus. Why H plus? Because I have plenty of them, because it's an acidic. I told you when the water is not, when the hydrogens are not balanced, you add H plus or OH minus depending on which medium you are in. So, guys, this is the final equation. Now add these two both the equations up, and you get the final equation of this lead storage cell as well. Are we getting this, guys? Then the next one is nickel cadmium cell. Here there is one small thing that you have to remember. In NCRT, even in the equation based topics, you would be able to see there is a discrepancy. What actually happens is the anode is not really a problem, which is cadmium. You can understand cadmium is becoming Cd2 plus. That's not a problem. Problem is the cathode. The cathode in here it is written as NiOOH. In your NCRT it is written as NiO2. It is written NiO2. But when they would start the reaction, they would start with NiOH whole thrice. Check it right now if you have the NCRT with you. NiO2 is what they're going to call the cathode. But when they would start writing the equation, they would write it as NiOH whole thrice. From there, they're going to convert it into NiOH whole thrice. Have a look. Found it? Oh, the cathode anode is not mentioned. So I am mentioning the cathode and anode figure. Don't write this as the cathode. The cathode is actually NiO2. With NiO2, nickel oxide is the cathode. When you have the electrolyte as KOH and water, the cathode actually breaks and it forms with, after reaction with water, it forms NiOH whole thrice. So guys, their cathode is NiO2, but the reaction when you write it, it would be NiOH whole thrice. From there, you have to write the equation. Just remember this small thing in here. So NiOH whole thrice to NiOH whole twice is the conversion you need to do in here. So let's do it, guys. So it is plus 3. This is plus 2. So first, let's balance the nickel, which is already balanced. I'm not going to pay attention to the oxygen and the hydrogen because I have to balance them later on. So guys, the first thing is to balance the oxidation state. So for that, I'm going to add 1 electron in here. After oxidation state, I'm going to get rid of these numbers. So overall charge on the left hand side is -1 because I have an electron. So the right hand side, I need to put an OH minus. Why OH minus? Because that's the medium I have. It's type KOH. Basic medium, isn't it? So OH minus. So the electrons are balanced in both the sides. Now after that, balancing of oxygen. See, oxygen and hydrogens are balanced right. This was OH whole thrice. This is OH whole twice plus OH is OH whole thrice. Is balanced. Now here it was a 2 electron transfer process. Here it is a 1 electron transfer process. So you multiply the entire equation with 2 in order to cut those two things together. So guys, what's the final equation? 2, 2, 2, 2. Now you add them up. You're gonna get CD plus 2 NiOH whole thrice gives you CD2 plus 2H minus plus 2 Ni. This is the final equation we got. Are we now a little bit more confident about the cells now, guys? We have understood the logic behind this completely. See, we need to understand that whatever we feel a little difficult about, everyone feels the same way. So the questions are more likely to come from their own, from those places. So guys, right now you are in the situation where rather than finding out your weak point and strong point, now you have to completely figure out what you're afraid of and start working on that thing. Example, you have to go to the chapter called Chemistry in Everyday Life and start looking into the structures. Okay. So whatever you're afraid of, start looking into those things now. Okay. Now, the lanthanoids and the actinoids. I don't feel like you have paid more attention to these electronic configuration lately, right? So that's why I'm gonna give you this electronic configuration. First of all, guys, try to remember both the series. Okay. There are plenty of mnemonics in the internet. I'm not gonna make any dumb mnemonic anymore. So if you feel like you know the electronic configuration, still guys, write it once with me. Okay. I mean, you're the only one who said that, you know. I mean, he's saying, sir, your mnemonics are fun. You don't really know. No, I was taking a class 10 batch. I don't really take it, a special class 10. And they just told me certain things like, sir, from where do you find this dumb mnemonic? And I got demotivated. So I'm not going to tell you any mnemonic anymore. Right now, the kids are not like you know. Okay, let's start with the first thing, the lanthanum. I use that, sir, I use that science teacher one only. Really? You guys are now giving me confidence. Okay. Yes. Now focus. For lanthanum, it is 4F0 5D1 6S2. So guys, it suddenly asks you from where the lanthanoid starts. The answer is not lanthanum. From cerium it starts. You can clearly see it is not an F block element because there is no electron in there for that. Right? So lanthanum is not the first element of lanthanoids. It's cerium. Now, cerium, what actually happens is the first electron comes in 4F. 5D1. Now tell me, Harshini, what would happen in praseodymium?
4F2, 5D1, 6S2.
No, it would become 4F3, 5D0, 6F2. Actually, what happens is, guys, this is 5D and this is 4F. Okay. Now, when one electron comes in 4F, 4F and 5D becomes energetically equal. Then when the second electron comes in 4F, the third electron from 5D also jumps to 4F. So you get 4F3, 5D0, 6S2. So guys, this is the thing that you need to remember in here, praseodymium's electronic configuration. Then comes neodymium. Neodymium is now you can just follow normal trend. 4F4, then 4F5. Keep the 5D0 the entire time, guys. Just write it down with me once, even if you feel like you know it. 5D0, 6S2. Then samarium, it would be 4F6. Europium, it would be 4F7. Now, step on your brake now. The moment 4F7 has reached, Pradarshini, do we know what's going to happen now? Definitely. But what would be the reason behind it? What would be the, outcome of that? Outcome in electronic configuration, what would happen? Very good. That's correct. Now, you might be thinking, guys, it would be 4F8, but no. As it is half filled, the second electron would go in the 5D1 again. This is the exact question they asked. In GD3+, what is the reason behind stability? Answer was exchange energy. Why is the half filled stable, half filled orbital stable, guys? Because they can interchange between themselves, right? We have discussed about this. That's called exchange energy. Okay. And the orbitals, they get paired up. This is called pairing energy. Pairing energy and exchange energy. Two things. They work against each other. Then, guys, again from TB, DY, holmium, erbium, you just go like normal trend. So it would be 4F8, it would be 4F9, it would be 4F10, it would be 4F11, 5D1, 5D0, 6S2, 5D0, 6S2, 6S2, 5D. Okay, any doubts? Is it clear? Tell me. Just write it down in the chat real quick. Very good, Priyadarshini. You're the only one who got this. Didn't see it coming, isn't it, guys? 4F7, 5D1. The next one wouldn't be 4F8. Yes, it would be 4F9 because this one electron would also come here. So 7 to 8, then the 5D electron. 9. How to memorize the configuration? Again, you don't have to memorize the configuration. Just see which all things which is changing. Just write it once or twice, you get it. From praseodymium, you get this thing, one happens once, and in gadolinium, it happens once. That's why in another place it's going to happen. That's why whenever they ask the question, they ask from here on. In another place, it's going to happen, guys. Do you know why it's going to happen? Very good. Can you tell why the D gives electron? Like I said, you know what actually happens is, do you remember the Bohr's correspondence principle? Like, more you go higher in the energy level difference goes down. So like, let's say energy 1 and energy 2 is having this much of difference, but more you go up, the energy differences coming close to each other. So 4F and 5D are very close to each other actually with respect to energies. So when the electron can come into 4F, 5D, when the electron can come into 4F, that has a very minute difference. And that is going to be even more minute in actinoids, guys. So your mind is going to blow the moment I show you the actinoid electronic configuration. Okay. Right now, this is the alanthanoids. Then TM, it is going to be, what am I right now? 4F13, no? 12. 4F13, 5D0, 6S2. Now, there we go. 4F14, 5D0, 6S2 in ytterbium. In ytterbium, guys, I have 4f17, 14, 5d0, 6h. And now you know that it is fulfilled. So what would happen, Laksha? The next electron would go where? 5d1, 6h. Okay. So these are the electronic configuration of lanthanoids. Now you go for actinoids. Write it for once or twice, it would be memorized. So, do you want to hear my mnemonic here, guys? You said yes or no? I didn't know that. So it is a lame one, but try to. It might help you. Okay, it might help you. So what actually happened is, you have seen those movies that is called Avengers. Have you? There are those superheroes, right? So it's on the basis of that. Okay. So actor, you know, there was an actor called Thor in there. So actor Thor protects the actinium, thorium, protactinium. Protects. So you have seen that there was one movie that I was watching. I don't really watch these things, guys. This is that I do for you guys only, so that I can correlate with you. See how dedicated I am. So actor Thor is protecting. So what is he protecting? So there was one Avenger movie of Thor, which is known as Thor Ragnarok. So it's a keep science beside when you listen to this story. Okay. So what actually happens is that guy is saving not Earth, he's saving different planets as well. Okay. And so here he is saving uranium, Neptunium, plutonium. So Uranus, Neptune, and Pluto is what he is saving, right? So actor Thor is protecting Uranus, Neptune, and Pluto. Now, from where is he protecting it? See, if you have noticed this movie, he is actually from America. So he is protecting all these three planets from America. Americanium. Okay. Just one sec. Sir, they watch the movies. You should ask AI people to sponsor the trip since you are working for the students while. Oh, askIITians. Okay, so you watch the movie. You should ask the askIITians people to sponsor the trip since you are working for the students while watching the movie. I mean, you can do it. You can go like Anik sir was saying, if I watch some movies, then I would be able to pay more attention to these mnemonics. So askIITians should pay me some money so that I can go to the movies and watch them. How's the plan? Keep me in CC and send the mail to the support team today. Okay, done? Great. Okay. Now from America. And that's the end of the story, guys. So I have a now new mnemonic for the rest of them. Because anyways, I'm a student of science, isn't it? इससे ज़्यादा art नहीं निकलेगा मुझसे. Now the second mnemonic that I'm going to tell you is about the science of the what do we call it? The scientists. Okay. So Curie and Berkeley. I've heard about both of them. Curie and Berkeley. Berkeley is a very famous institute out there. So Curie and Berkeley. So this is Curium and Berkeleym only. And they are actually coming to California. So Curium and Berkeleym, Curie and Berkeley, they are coming to California, means California. To do what? They want to meet Einstein, Fermi, and Mendeleev. Einsteinium, Fermium, and Mendeleevium, who are actually Nobel laureates, Nobelium laureates. So Curie and Berkeley, they are coming to California to meet Einstein, Fermi, and Mendeleev, those who are Nobel laureates. I don't tell this mnemonic to anybody because I feel like you need to remember more, isn't it? इससे ज़्यादा नाम ही याद रख लेते हैं. See, whatever helps you. Don't really know, isn't it? Now, here the fun fact is now, for actinium, this is just like the lanthanoid series, guys. Okay, so lanthanoid we started with 4F, right? This would be 5F. 5F, 67S. Just increase it by 1, 1. So 5F0, 61, 7S2. Now thorium is 5F1, 61, 7S2, just like before. Now, here protactinium, earlier in praseodymium, what actually happens is, guys, then it becomes 5F3, right? Here it's not going to happen. It's going to be 5F2, 6S1, 7S2. Then 5F2, 6S1, 7S2. Then, 5F3. Then here 5F4. Here 5F5. Here 6S1, 7S2, 6S1, 7S2. After plutonium, you're smart enough to understand this. Okay. See, fine. Now from americium, what you have to do is, guys, now this 6D would lose the electron. And now it would become 5F7. 6D0. Now from here onwards, you just follow the norm. So this is going to be 5F8, 6D07S2, 5F9, 5F10, 5F11, 5F12. Just one sec. I made a mistake. Just one sec. In neptunium, after neptunium and plutonium, we need to change this, guys. 4F4, 6D1, 7S2. So this would be 5F6, 6D07S2. This would be 5F6, 6D07S2. Then the next one will be 5F7, 6D07S2. Now, as it has reached 7, the next electron would go again in 6D1. Isn't it? Half field configuration. So again, that thing would happen, that 6D electron would gain it. Now here, 7, 8, 9. This is. Now in the Berkeleum, what actually happens is 7 becomes 8 and the 6D electron comes in here. So again, 5F9, 10, 11, 12, 13, 14. So still here, guys, everything remains the same. But here again, as it is fulfilled, 1. So this is the electronic configuration for the atoms. Okay, guys, just write them once or twice. It is written as thorium is given as 62. Thorium 62. All right, guys, I will just look into this. If it is written in the textbook, then just follow that. I don't think so. I am wrong here. Electronic configuration. Okay. Here now. Yes, they are right. They're right. This would be. Yes. Then in praseodymium onwards, everything is fine. I forgot this. See. So guys, here there is another change that happens. So what are the changes happening here? So here from thorium you got a change. And remember, the next change is happening in plutonium. Then in curium, because you have achieved 5F7, 4F7, and then in lawrencium. These are the 4 changes which are happening. Just write them once or twice, guys. You are not really, it's not like you're definitely going to get this question, but you might get it on the basis of the last year question paper. I'm saying. Okay. So that would be it for today, guys. In 27th, today is 25th, right? In 27th, you have the organic paper. So prepare for that. Again, I'm going to give you 50 questions in organic chemistry, which would be more than enough for your preparation if you just go through those type of questions from the book. All right. So that would be it then, guys. Bye, everyone.
Thank you, sir.
Bye. Welcome. Bye, Nate.